respiration, this is another chemical reaction. This is another chemical reaction that involves a change in energy, okay? And so cell respiration is breaking down sugar into ATP. You guys remember ATP is adenosine triphosphate, and it's a high energy molecule. 3 phosphate groups means it is high energy. Okay, so cell respiration, and I guess we should back up, right? Remember we said this is not the same thing as breathing, although it's related, because one of the reactants that you need for cell respiration is oxygen, and we get that into our bodies by breathing. It's not exactly the same thing. This is a chemical reaction. And so the reactants are going to be sugar, and the products are going to be ATP. This reaction is the opposite of photosynthesis. Let's put a little star by that, because we already learned photosynthesis yesterday. So everything that we learned yesterday, flip it around, and that's cellular respiration. In photosynthesis yesterday, we started with low energy carbon dioxide, and we made high energy sugar, right? Now in cell respiration, we're going to do just the opposite. We're going to start with high energy sugar, it's in our food, and we're going to break it down into low energy carbon dioxide. And that energy that gets released is going to be captured in ATP. So what is it? It's a series of chemical reactions. Let's underline chemical reactions. It's not just breathing. Organisms that don't breathe, for instance, bacteria, they don't have lungs, right? They still do respiration. Who does it? All of life. All of life does cell respiration in some form. It doesn't look exactly the same in all of life, but all life, remember, needs energy, and this is how cells are able to take energy from their environment in molecules and make it into ATP. Where does it happen? It happens in the organelle called the mitochondria. You guys remember we talked about it. We said it's the powerhouse of the cell, right? Maybe a better way to say it is that it's actually an organelle where cell respiration happens. It's not as catchy though, right? We say it's that, but it's an organelle where cell respiration happens. So maybe we could draw an arrow and we can label this is where cell respiration happens. Okay? Any questions? All right. Okay, well now let's get into the nitty gritty. Let's talk about what is the actual chemical reaction. What are the things that are moving around and changing inside of cell respiration? Okay. You guys see I wrote it, again, the same way that I did yesterday. Here it is in words, right? Oxygen, glucose, water, carbon dioxide. And then below it, it's the same thing written in symbols. But before we get there, let's go ahead and circle the arrow. Remember that arrow tells us that at that moment, bonds break, atoms rearrange, and new bonds form. And so everything that we start with here on the left side, we call as remember, it starts with an R.
Reactants.
You got it, the reactants. Everything after the arrow, this is like baking a cake, it's cake itself, are the products. So we start with reactants, they're the ingredients, we mix them together, and at the end of the chemical change, the cake that we get at the end is the products, right? And so oxygen, the chemical formula for oxygen is right here, O2. The chemical formula for glucose is right here, C6H12O6. The chemical formula for water, of course, is H2O. We all knew that, right? The chemical formula for carbon dioxide is CO2. And the ATP, of course, that's not a chemical formula, that's an abbreviation for adenosine triphosphate. But this is where the energy is stored. It says it just up there, so maybe I'll just... There we go. This is the stored energy, right? ATP is a high energy molecule. It's got 3 phosphate groups and 2 unstable bonds, and that makes it high energy, okay? Okay, so over here on the right, here's our graph again. Let's go ahead and label a couple of things. We're starting with a high energy reactant. So let's write in C6H12O6. That's our reactant at the beginning of this reaction. And over time, the reactants become products, and in this case, the products are lower in energy. The low energy product of cell respiration is carbon dioxide. That's what we breathe out. Did you ever wonder, where does that carbon come from that we're breathing out? It came into us as food, right? So the food that we put in our mouths and chew up and swallow gets breathed out of us as carbon dioxide. And the energy change is that the energy is going down. And so you guys remember, that means when the energy is going down, that means energy is released, right? And in this case, the energy is released so that we can make, there we go, to make ATP. Okay, energy is released so that we can make ATP. Any questions so far? Basically, big picture, we're starting with high energy sugar. What's that, Jenna?
Shouldn't it be ADP where energy is released?
You're right. This is good. I'm glad you pointed that out, Jenna. Let's not put ATP right there, because that makes it seem like it's low energy, doesn't it? Let's erase that, guys. Good point, Jenna. I thought of that, but I didn't think it would matter, but you're right. Let's say its energy is released. Maybe we'll draw it over here, okay? To make ATP. And you're right, ATP is a high energy molecule. We don't have to draw this, guys, if you don't want to, but Jenna, you might want to. Right? So she was pointing out ATP is supposed to be high on the y-axis. Good catch, Jenna. Okay, so let's talk about each of these chemicals. Where do they come from? Where do they go? Oxygen comes from the air, right? We breathe it in. And ultimately, how did it get there? You guys remember yesterday? How did the oxygen get in the air? It got there because of photosynthesis, right? Photosynthesis produced it. Oxygen in the air is used to make water in cell respiration, which of course we can use as urine. Glucose. Glucose comes from our food, right? We eat food, and that's where we get our sugar from. That's used to make low energy carbon dioxide. So we eat high energy sugar, glucose, and we make low energy carbon dioxide. And that energy change is used to make ATP. So we're using that energy to make high energy ATP. Remember, ATP is like the gasoline that powers our power tool enzymes, right? A chainsaw that doesn't have gasoline is worthless. You've got to have gasoline. And so ATP is the gasoline. Water we excrete as waste. If you want to jot down, that's part of our urine. That's a urine. Carbon dioxide, of course, we breathe it out. And then the ATP temporarily stores energy for the cell. Maybe we should jot down, it's the gasoline. It powers our enzymes. Okay. Any questions? That's it, Ms. Friscala. Thank you.